So the inner ear is an area for equilibrium and hearing. But there's two structures in there that are quite complicated. And I don't know, I'm not sure if you know what this word means. And I don't mean that in the sense that like, oh God, how could you not know what this word means? But it's kind of a word that I don't know, maybe it's a little archaic. You don't hear it much anymore anyway. But the word is labyrinth. And a labyrinth is sort of a maze, right? That's really kind of, it comes from Greek mythology. So it's a maze, but it's not really that complicated in the ear. But inside the inner ear, there are two mazes, or two labyrinths. One is called the membranous labyrinth, and the other is called the bony labyrinth. And the best way to picture this, and it's sometimes hard to picture, even the pictures in the book don't really do it justice, I don't think, is the membranous labyrinth is surrounded by a bony shell. And that bony shell that surrounds it is called the bony labyrinth. But both of these mazes are filled with fluid. And the fluid is what's responsible for those pressure waves. The membranous labyrinth is filled with something called endolymph. I've often heard it described as being roughly similar to blood plasma. But it's got ions and other things in it which are really necessary for the receptors for hearing and equilibrium to function. So there's that fluid. And then there's a second fluid that in the bony part of this structure called perilymph. I know that we could probably find better names for them, but of course I didn't name them. So membranous is endo, and bony is perilymph. And like I said, the fluid is necessary for the function of the function of the ear. It's not like everybody maybe you go swimming or something like that. You get like I gotta get water in my ear or something like that. Well, that's but this is always there. You can get rid of the water. Maybe jump on one leg or something like that, or wear earplugs. Anyway, so that's the inner ear. More details to come. Now, here's where like this big model comes in, or any of the ear models sort of show it, but this one shows it, I think, the best. The bony labyrinth is divided into a couple of different regions. The vestibule, which contains two structures called the utricle and the sacule. Cool names, right? The semicircular canals and the cochlea. Right? Those are three structures of the bony labyrinth. But if you just do this, I'm going to use this because you can all see it. If you just take this part, the semicircular canals, leave out the snail shell, just kind of all this stuff here without the snail shell, the utricle and the sacule and the semicircular canals, this area is called the vestibular complex. And it's this area that's responsible for equilibrium and balance. This one is responsible for hearing, right? But in a way, it kind of shows like the outer bony covering and the which would be the bony labyrinth, sort of maybe an inner area that you can see in there, which would be the membranous labyrinth. Right? So you do need to be able to recognize these structures, the semicircular canals, and also the utricle and the sacule. You can see that the utricle and the sacule are important for telling us about gravity, which we always know about, and also for acceleration. And I've read, maybe you've heard, that the astronauts, space shuttle guys and girls, and the guys and girls who live on the space station, right? One of the things that they don't have, of course, is gravity. And much like seasickness, which of course has nothing to do really with gravity, but more motion, it takes some getting used to. Space sickness, right? Because let's face it, this is confused now. It's been used to a life in gravity, and suddenly you put it someplace where things just float away in front of you. This thing takes a while to figure out what's going on, to be able to reprogram the brain to figure out what's going on. Another big problem, of course, with prolonged spaceflight, if we're ever going to go to the other planets, is in zero-G. The muscles and bones begin to get weak, and because you can't run, right? You got nothing to push against, so that's why they've invented some very interesting sort of treadmills for the space station where you tie yourself in place, or a bike which you're trying to ride at zero